Thank you, John, for joining and for accepting the invitation to be with us today. We were we the subject that you are covering, it's biological AI for nature and equity-based economy. Just a few words about John Klippinger. You are a researcher, entrepreneur, and activist around decentralized self-organizing systems with the focus on generative governance and finance for climate change and social equity. And we could not have our subject on structural change without your input. So it's more than welcome your presentation, and thank you again for joining. We will have around 30 minutes of presentation, and of course, if you have questions, comments, we are expecting them in the chat or by raising the hand for those that you've not used Zoom for a long time, maybe from the pandemic. It's you have a button there, reactions, and there you can raise it, or just turn on the microphone and jump in the discussion. John, the floor is yours.
Good, thank you very much. It's a pleasure to be here. Can I a little sort of situate this, given the context in which this is being presented, and why I think the notion of biological AI and what biotic AI is really important. And I think in the context of this particular session is like rethinking structure, what's going to be the structural changes that go forward, and particularly what a major role AI has. Now, just to give a little context, my background, I did my PhD in computational linguistics and AI, and I started a number of companies, and I've also spent a number of time sort of in the intersection of technology and law. And I was at the Berkman Center for a number of years, started something called the Law Lab. But and from my vantage point, very much from the perspective of how technology and policy interact and create new kinds of paradigms for thinking about governance and equity. And I've been particularly interested in issues of sustainability and climate change, and was involved in setting up a group called Open Earth Foundation, started a company called ClearTrace. But my recent interest is with a company doing open source work on sort of biological AI. So I just want to give a context for this. And the idea that we're coming to is the power to create and deceive. I mean, it's enormous. It would be synthetic biology, it would be AI. We are unleashing a whole new set of technological capabilities that really never existed before. And so we need, I think there's a real challenge in terms of how to think about it and the magnitude of its impact upon us. The idea of the AI dilemma, and when the New Yorker cartoon, I don't know if you've seen this, where have the Escher diagram, and it's who defines whom. I mean, is the machine defining us, or are we defining the machine? And this is sort of foundational dilemma. And a lot of what we're seeing is in the conversations today, the policy, is to really look at the machine. There's been a whole argument talking about Moloch. This is abiotic AI. It's a machine, it's intelligent, the machine is going to dominate us. And that is the current narrative that you're seeing that's coming out really across the world. And it's really based. I love this other cartoon here. It's also the New Yorker, and I'll read the bottom. Is to think this all began with letting autocomplete finish our sentences. I mean, it's not actually, that's not entirely wrong. There's something called Markov chains, and that's sort of the underlying technology of this. So as it builds up, suddenly we have these missteps. But it really is a notion of AI that is basically sort of this omnipotent machine. And I was at the AI lab at the time that Marvin Minsky actually made this comment. And I'll read that. It's just 3 to 6 years, we'll have machines with the general intelligence of a human being. If we're lucky, they will decide to keep us as pests. Well, that was 1970. But still, he was the advisor for 2001. Marvin was a major figure in it, but this is sort of the de facto notion of what we thought machines would be. But it's really this. It's more of a projection than to say this inherent in the technology. And so this is really a manifestation of how people think about things. And there was when I was at MIT, there was a Joe Weizenbaum did this, and people probably famous know this. The ELIZA program. It was a very simple program that seemed to simulate a psychiatrist, and you would just tell something that was respond, and people projected all sorts of particular powers on this, and it became its own phenomena. But that, that was more indicative, and certainly the technology is a lot more sophisticated now. But there is a sense of projecting onto the technology certain things that really are socially constructed on our own side. And I think we're looking at this phenomenon of AI, and I know you can't read this. Second, well, let me interpret the important points. And this is from the Gartner group, in which they call a hype cycle that technologies go through. And I think the relevant information here is comparing different kinds of technologies in the AI arena. And what we're talking about right now are these large language models, transformers, generative models. And what you'll see is that by Gartner's consideration, the generative AI is like 5 to 10 years away, and particularly things like artificial general intelligence and what they call AGI, which everyone is sort of fearful of. They say greater than 10 years, big question mark. And that's present in terms of these little squares. But if you look at first principles AI, it's like 2 to 5 years, and causal AI, which is very related, 2 to 5 years. And this is what we're talking about, is that there really has been a transformation in the fundamental science and integration of different sciences and technology that is providing a new kind of AI that's sort of science-based. The same argument you'll see coming out of DARPA. DARPA has a recognition of different generations of AI, and they'll say the current generation is generation 2. They're saying AI generation 3, what we call it's an active inference AI, based upon sort of first principles, where you have things that can abstract and reason and reflect upon themselves. And what we're seeing is the current limitations of large language models that are sort of pervasive now, or transformers. They're really black boxes. They're built on a huge text corpus, and they're sort of bound to that text corpus, and they cannot reflect upon themselves. They can't correct. They have no internal causal models, internal representation. Nor do they have really any kind of independent criteria for determining what their ground truth is, how to selecting them. It's sort of intersubjective. It's subjective based on the criteria of the different companies. And it cannot explain or adaptively update its models and intrinsically measure their level of uncertainty or risk. This is another limitation the next generation models seem to have. And I think what this is applied to the commercial implications are quite significant. And this is where I think it's a projection. Yes, they're talking about regulating AI. We have all these events in the UK, the US. But in fact, they're still part of a very extractive parasitic business model. And that's really going to, in my view, is going to dominate the whole how it's regulated, not regulated. I was very active in areas of privacy and security and early social media at the Berkman Center, particularly Facebook. We knew what we had to do, giving people protection of identity and data, and it's never really succeeded, and that was 14 years ago. And so there are incentives for misinformation, deception, and false claims. I mean, so this is inherent into part of the technology and how they're thinking about it into the business model, and then you have a lot of concentration. And the fact that the cost of building these systems in this way is very expensive, the massive computational cost in generating and updating the models. But to that, and the thing that's really interests me is an emergent. There's a new science coming out. There's a collective cognition grounded in nature and the biology of living things. This is something that's relatively recent, and it really goes back to this concept of there's an inherent ordering principle of nature called free energy principle that goes back into physics. You can have Hamiltonian, least action, stable action. But these things are now being built upon and built and translated into computational models. And this sort of these principles apply at all forms, at all scales, in different kinds of forms. And I say the living thing acts to reduce uncertainty. It's this idea of a life and the brain as a predictive engine. And I think one of the founders of this is Judea Pearl. People are familiar with his work, but he was very instrumental in developing a notion of causal modeling and statistics. He won the Turing Prize, and he was really the discoverer of something called a Markov blanket, which is an extension of a Markov chain. And when you think about the underlying technology in a lot of this current AI, it is sort of based upon Markov processes, nested Markov processes. What's interesting about the Markov blanket, and I won't go into too much detail, is how do you identify something as being separate from something else? So they talk about external states, observer states, internal states, and action states. It's at some point when something can measurably be separate from something else that you can talk about new causal relationships. What's happened is that there's a physics of living things developed by Carl Friston. It's funny that a lot of the people in AI space don't know who he is, though he's 270,000 citations. He's really the paramount neuroscientist, computational neuroscience. He's also an MD and a physicist. And he has a notion of a scale-free, domain-free science of living things. And so that is, to me, that is really a very compelling direction is happening in AI. There's not, I would say it's the next generation. There's also work that's being done by Michael Levin, who's a biologist, computational biologist, 11 Labs and the Allen Discovery Center at Tufts. And I put Chris Fields in here because Chris Fields is a physicist on quantum information theory, which should tie in new notions of biology. But here's their goal, which just sounds really remarkable, is our goal is to develop generative conceptual frameworks that help us detect, understand, predict, and communicate with truly diverse intelligence, including cells, tissues, organs, synthetic living constructs, robots, and software base. So this is very different since the paradigm that is being currently talked about. But this is really grounded in biology and physics. And it is a principle-based way of looking into and understanding multiple intelligences. And so what this sort of reflects itself is and I love this trefoil concept of it. Is biotic or biological AI sort of has this old sense of coherence. And that sense of maintaining coherence is ability to achieve its perception, action, and prediction. These are the key concepts of what it means to be intelligent, just to be alive. So one part of the recognition of a system is to be able to see things outside itself. The other thing is have something internal to itself, and another one is to make predictions about future things. These things all interact together. And from that, we start to develop the concept of bioforms. Really, can we recognize and design things as living things based upon these principles? And because each living thing has a boundary of itself. It's trying to, you can look at life, it has a metabolic cycle that it keeps alive. And so in order for it to keep alive, this ties into the Markov blanket, it has to make predictions and actions that maintain its particular state, what they call non-equilibrium stable state. So there's a capacity to model, predict its environment, itself and others, it's self-organizing, self-healing, is self-replicating, which is very different than your current models. And it's symbiotic. It evolves in complexity and mutual synchrony with other living things. This is very important. I think when we start thinking about economic models and governance models, these things, we're recognizing that the preservation of something is dependent upon the preservation of other things external to it. And since its intelligence or sentience is situational, its intelligence is grounded in its survival. So there is really no sort of uniformly superior form of intelligence. And a good indication is that, is there a superior body type that exists in all types? So no. I mean, there are different body types that are situated for different kinds of adaptive selection. Same thing with intelligence. So there is this notion of how do we have a ground truth in AI. This is a really huge challenge, given that it's so easy for these models to hallucinate and for them to generate misinformation, very credible information, and when it's maybe financial incentives to do that. So there is this need to have data model providencing, knowing where your data comes, and securing it, privacy, verification, the proper attribution. This is very difficult to do in the current models that you're very concentrated. And what you're seeing is a trend to make them more decentralized and have localized models, which you can do authenticate. But what I'm getting at is and this will sort of wrap things up and help the conversation, is I think we're getting a computational scientific method for the North Star of a sort of next generation. In other words, of applications. In other words, how do we know we can trust something? How do we know it's principle based? There's a way of applying the scientific method in order to validate different claims and stuff. And so what I just sort of end on this sort of presentation is that AI will really be everywhere. I mean, I think we have to come to the terms with that there are so many applications it's going to be underpinning. It's extremely important that it's being properly understood. And a lot of the current regulatory frameworks that are being applied, the older regulatory framework from an old paradigm, I've been in and out of government. I've worked in regulation in a number of different areas. There's a cottage industry of how to do this, and people making various careers and franchises on top of these things. But in terms of the current framework, I don't think it's work. You're going to think about technology, embedding in the technology certain principles that actually control the technology. So sentience or intelligence will be a measured embedded feature of every application service. You can't make it an afterthought. You can't be a whack-a-mole. Say, oh, this thing got off the rack. We'll figure it out. It has to be principle based. And I think you're going to need new business models. I think until you have a different business model that recognizes the cost of negative externalities and be able to build something that doesn't have encode those externalities, then you're not going to be able to effectively control this. And again, the ethics of AI will have to be encoded into the application, and you can't do that with the current set of what I call the abiotic models. You can only do it through the biotic model. So I'll sort of leave that and sort of open it up to questions what people want to have and see provoke the conversation here.
Thank you so much, John. I think we should have had like 1 hour for this at least.
Well, I know there's a lot of information that's being is being put out here. And it's always sort of way of provoking discussion and getting people to sort of back and forth. But that I just wanted to sort of prompt this discussion.
Mm-hmm. So let's see who has any questions, comments. They are of course more than welcome. I would, until people will come up with their own questions. I was a bit intrigued about one of your slides where you were mentioning this. You're quoting this. Our goal is to develop generative conceptual frameworks that help us detect, understand, predict, and communicate with truly diverse intelligences.
Right. From the
cells, tissues. And I remember, but unfortunately, I don't know the name of this company that actually got into trying to decode the communication of plants. So they were studying intensively for a few years, and then they were very, very close to getting very simple signals and to translate them to, let's say, words, what we use. And then they got kind of scared. It's like, what are we doing here? What's going to happen if we would know what the birds on a wire are talking about, or talking about us or other things, and the plants, etc. So what do you think what should we use in order not to get into something dangerous that will debalance the whole natural ecosystem?
Well, I think we're that's what we're doing right now. And I think and I think and it's our ignorance of the ecosystem and how it functions. We think of it in mechanical terms, not in complex biological terms. And I think the point of this, and Michael Levin's point is that you have at multiple scales, you have very complex conversations, so to speak. You want a conversation, communications going at the cellular level, organ level, across all living things. And this is not something we recognize. And so if that's sort of foundational and we start to understand these interdependencies, is something we need to understand. There are methods. I mean, one of the things is, I mean, the challenges here are very significant because you're actually creating new kinds of synthetic things to create their own language. There's Carl Friston I mentioned earlier. The idea of having different synthetic agents generate their own language is very real. And it's not just a limited language. It's saying, well, can you have the expressiveness of English or any natural language? So we're on the cusp of a very dramatic way of rethinking our place in nature, and how nature functions, and where a technology fits or does not fit within that. But we're at the same time we're creating a lot of technologies that have enormous amount of power that we don't fully understand. And I don't think that I think we have. I'm of one that believes that the way to deal with these things is deepen your understanding of it, but not necessarily really. I think as you start to understand it, you're going to be able to naturally curtail it. You're curtailing abuses of it, and I think part of our abuses are intentional. I think part of our out of sheer ignorance.